it's me again. This time I'm going to discuss example 1 under section 6.5, more volume problems. This time, we're going to find the volume of a cylinder of radius r and height h. Now, as we mentioned before starting this example, we really don't need to use an integral to find this volume, but it is a good example to illustrate the method we'll need to use for these types of problems. We'll start off with a sketch of the cylinder below. We'll center the cylinder on the x-axis, and the cylinder will start at x is equals to 0 and end at x is equals to h as shown. Note that we're only choosing this particular setup to get an integral in terms of x and to make the limits nice to deal with. There are many other orientations that we could use. What we need here is to get a formula for the cross-sectional area at any x. In this case, the cross-sectional area is constant and will be a disk of radius r. Therefore, for any x, we'll have the following cross-sectional area. A of x is equals to pi r raised to the power of 2. Next, the limits for the integral will be 0 less than or equal to x less than or equal to h, since it is the range in which the cylinder lives. Here is the integral for the volume. V is equal to the integral of h, and 0, pi raised to the power of 2 of d of x is equals to pi raised to the power of 2, integral of h and 0 of d of x is equals to pi raised to the power of 2x, integral of h and 0 is equals to pi raised to the power of 2h. So we get the expected formula. Also, recall we are using r to represent the radius of the cylinder. While r can clearly take different values, it will never change once we start the problem. Cylinders do not change the radius in the middle of a problem, and so, as we move along the center of the cylinder, for example, the x-axis, r is a fixed number and won't change. In other words, it is a constant that will not change as we change the x. Therefore, because we integrated with respect to the x, the r will be a constant as far as the integral is concerned. The r can be then pulled out of the integral as shown, although that's not required, we just did it to make a point. At this point, we're just integrating d of x, and we know how to do that. When we evaluate the integral, remember that the limits are x values, and so we plug into the x and not the r. Again, remember that r is just a letter that is being used to represent the radius of the cylinder, and once we start the integration, it is assumed to be a fixed constant. As noted before we started this example, if you're having trouble with the r, just think of what you do if there was a 2 there instead of an r. In this problem, because we're integrating with respect to x, both the 2 and the r will behave in the same manner. Note, however, that you should never actually replace the r with a 2, as that will lead to a wrong answer. You should just think of what you would do if there was a 2. Thank you.